So we're going to have it's like pair programming, but now it's going to be pair presenting. Vladimir and Dimitris. Dimitris, okay. Can I have a round of applause? And you ready?
Just to connect the Mac. Okay.
What is that? Yeah, just hit play.
Oh, okay. Hello, everyone. I'm Dimitris Koulouris. I'm full-stack developer at Warply from Greece. So our company's backend is totally written in Python. We found the Pythonic way it's easier than the different approaches we tested. And that's why we're here today, to present this approach of processing billions of events with Python in real time. That's one of the reasons. A few months ago, we started to organize PyData Athens in Athens to exchange ideas and share our experience. And that's why we're here today. So we're very happy to be here after your invitation. Okay, let's start. In the first part, we're going to explain to you what data do we process at Warply, why data analysis is important, and how we do it. And the second part, Vladimir will show you more advanced techniques we use at cold processing and machine learning techniques. So, at Warply, we have a lot of data we process by the services we provide at our customers. In a few words, we have mobile and web marketing plans so that our customers can send communications to multiple channels, mobile applications, websites, SMS, mails, etc. E-commerce platforms, they can create these shops with a lot of automation rules, policies for pricing, couponing, what else? Loyalty solutions. We have finance person-to-person and person-to-business services and mobile wallets, keyboard payments, content management, produce a lot of data, blog posts, newsletters, news feeds, and some other like IoT services with beacons and other services. So we have a lot of data, and we have to process them in order to give our customers the best experience and best insights they use on day-to-day operations. So why data analysis is important? In general, data analysis help organizations harness their data and use them to identify new opportunities. This process leads them to make better decisions, more efficient operations, higher profits, and of course, happier customers. Yes. Moreover, identifying and refining audiences. When customers have a big database of users, they need to create smart segments of them to, for example, offer a special deal or retargeting them or other marketing issues. So, in this diagram, we show you our infrastructure. So we used to process all the data in two streams, hot processing and cold processing. I didn't include some components like firewalls, push and mail servers that are out of the scope. So, as you can see, the first step is the clients. We gather data from multiple sources, like I said before, apps, websites, stores, third-party services. All of them produce massive amount of data. So this data, these requests are processing to a load balancer. The load balancer has the responsibility to distribute all the requests to the application server. That's why, because one application server on its own cannot satisfy all the requests. So load balancer optimize resource uses, maximize throughput, and minify request response for the users. On the second level, we have the application server cluster. This cluster includes at least two application servers that it depends on the current traffic. We have a load elastic scaling solution that in time with a lot of traffic, we scale up or scale down to satisfy all the requests. So this level can satisfy all the requests of the day. Sometimes we have millions of events, so this is very important. Each application server has a lot of workers of Tornado Web framework to process the request and forward the responses back to the users. Then, after processing all the business, depending on the request of the client, we create a payload of the event created, for example, in transactions. This payload has all the information we need to for the analytics purposes or metrics we gather. This payload is forwarded to a Kafka. Apache Kafka is actually a distributed streaming platform for real-time applications. It's horizontal scalable, so on this level 2, we have we have scaling opportunities, so all the requests to be processed correctly. It's really easy to use. Actually, we have a Kafka server for a year now, and we haven't logged into the server to maintenance. So it's a really efficient way. On Kafka, we have 3 parts. We have the producers that produce the events. In our applications, it are the application servers. We have topics that actually are a group of events or streams. And we have consumers. Consumers has the responsibility to get that event, that message, and consume it depending on what we are going to do. In this presentation, actually we use the payload the application server has produced to write our analytics to our databases. All the hot processing stack is written in Python as well, and it's a really small code, easy maintenance, and easy to debug. Very, very important. On the fourth level, we have the databases. Actually, we have 3 different type of databases. We have Postgres for relational databases, transactional orders, application data, users data, and any other relational database we have to store. And we have a Redis cluster that's for caching solutions. So we have we can cache the responses to reply to our clients faster. And lastly, we have a Cassandra cluster. Cassandra cluster, it's for raw data. It's for data that we cannot store in a classic relational database. In Cassandra, actually, we store all the analytics, metrics, and other data that we produce during the hot processing and the cold processing that Vladimir will say next. What else? Okay, I have 3 slides with advantages of some services, Python libraries, actually, we use. Tornado, as I said, is easy, fast, and to set up. Fast responses, actually, it can satisfy 2,000 requests per minute easily if you use an Nginx or other load balancing application. It's far more, and they have a big active community. That's really important. When you have some issue, you can find all the requests just searching. Kafka advantages, as a messaging queue or streaming application, we use it. It can never lose an event. Any event, all the events on Kafka are stored, so until they consumed, it cannot be lost. We can have multiple consumers per topic. That's important for scalability. So if you produce a lot of events, you can actually create more consumers to satisfy all of them. There's no need to add or remove any code, any Python code on the applications, on the Python code. You just add a consumer, and it works. Actually, you can easily create an automation rule for scaling up or down, depending on the traffic you have. Again, maintenance and DevOps operations are automated. Third, each event can be published on multiple streams. What that means? It means that you can have one event that you have to consume in different ways. For example, you can have a transaction, a placed order on some store, and you have to store it on your database as analytics. And also, you have to inform some third-party service for that transaction. With Kafka, it's as easy as creating 2 topics with 2 consumers with a different code. One to store it in Cassandra, and one to call an API and forward the payload. Cassandra advantages is elastic scalability. You can, for scalability, you can just add one virtual machine or Cassandra node, and without even restarting cluster, it works. High availability and fault tolerance. When you have multiple nodes, the data are stored in different locations. So even one node it fails, the data are not lost. You can still retrieve it by automatically by the other active and healthy node. And lastly, it's high performance. Cassandra can store, retrieve, and satisfy multiple requests with even 2 nodes, and without a lot of resources. So this infrastructure we use the last 2 years, I think. It's scalable on multiple requests. Sometimes we have millions of events, and we had no problem. And the important part of all this is that we use Python that easy to maintenance, easy to write, easy to debug. A few years ago, we have tried alternatives, such as JVM options, such as Spark or Java code, and it was really hard to maintenance. With Python, it's really easy and easy to write and debug also. Okay, so that was part one. In part two, Vladimir will show you the code processing and in more detail the technologies and frameworks we use.
Okay, guys. Thank you. As you understand, we are all stressed a little bit, so it can happen to anybody. Dimitri, thank you very much. First of all, I would like to thank you all for being here. I feel really honored and very happy to be here today. You know, it's a great event. I will try to share with you some knowledge on data science topics gained at WordPlay. Before I start, you know, allow me to ask, how many of you are data scientists? Raise your hands. Okay, so 3, 4, 5, great. All right. So how many of you have used Dask, Pandas for natural language processing? All right. You're using only Pandas? Or, you know, in a combination with Dask, or it's mostly in Dask. So you pre-process all the data, you know, topically on your computer. All right, great. How many of you have used or are using Matplotlib? Plotly? Okay, so the guys over here. So I think that you will join this talk. All right. So, and also, do we have any marketeers here today? Because my part of the talk is going to be mainly focused on how the marketeers can adopt machine learning, deep learning, and various natural language processing. So do you have any marketeers here? No? No, okay. Okay, so let's get started. As Dimitri previously mentioned, WordPlay is a marketing and customer loyalty company with a focus on machine learning, deep learning, and natural language processing. We have lately undertaken a lot of very large-scale, let's say, projects, and we are doing really, really well. We use state-of-the-art algorithms, which are built by our research and development data science team, and use very modern and sophisticated libraries such as Keras, TensorFlow, PyTorch, scikit-learn, and many, many others. So everything is coded in Python and Pythonic libraries, starting with our machine learning and deep learning experiments that are done by our data scientists, and ending with the data pipelines, which are architecture and built by data engineers and backup developers. So as you can correctly guess, we love Python. We use it a lot. Everything is Pythonic. And of course, we love machine learning and deep learning, which of course enables us and, you know, I would say gives us wing to innovate on such many levels and deliver really modern and state-of-the-art algorithms. So let's see a little bit, you know, the agenda of this second part of the talk. I'm going to open this presentation with a brief introduction to artificial intelligence in marketing, what is the current state of AI, and what we expect to see in the next couple of years. Next, we will see what was our approach to bringing AI to our technology, to our company, and developing a data-driven culture. How we have broken down this general and very confusing, and I would say very high-level term, which is AI, into 3 different types of technologies, and how we have identified 13 types of AI techniques that helped us not to get lost in the process. Next, I will briefly mention our data pipelines, which allows us to process billions of events in real time. So my part of the talk, you know, it's not going to be very technical. You know, I'm a data scientist. I'm not a data engineer. So it's going to be on a very high level. Then I will talk a little bit about our environment setup, what kind of libraries we use to run machine learning, deep learning experiments, and deploy our analytic models to production. I will explain you how by using similar technologies and only Python libraries to train and deploy our models, we saved our team for many future problems. And finally, I will close this presentation with some design patterns for machine learning in production that should be taken into consideration by any company that plans to incorporate AI into its business. So this moves us to the next slide. So artificial intelligence, it's a very hot topic in the marketing at the moment. And it's often used as an umbrella term to describe different types of technologies that can be used to simulate human intelligence. AI can teach computers to parse data in a contextual manner, to provide requested information, supply analysis, or trigger an event based on their findings. So marketeers and marketing-oriented companies are already heavily leveraging the power of AI in order to automate tasks, to improve workflows, and to gain some valuable insights into their customers. We use machine learning and deep learning to find new patterns in our data lake and glean new insights and knowledge for a variety of use cases, such as promotions, up and cross-sell campaigns, and improve customer experience. Now, according to a survey conducted by Salesforce this year, it was a couple of months ago, over 51% of marketeers currently use AI, and an additional 27% are expected to incorporate this kind of technology by the end of next year. As you can see from the diagram, the anticipated year-over-year growth of AI is over 53%, which represent the highest growth over any living technology that marketeers expect to adopt next year, beating technologies such as connected devices, marketing automation, social listening tools, customer identity, and access management. Now, and as the volume of customer-generated data grows, AI computing techniques like machine learning, deep learning, and natural language processing are becoming increasingly important to data-driven decision-making. We will see how we implemented AI to better target our audiences, because I previously mentioned we're a marketing and customer loyalty company, and gained a competitive advantage. So, okay, which moves us to the next slide. When we started to adopt AI in our company, we got a little bit, in the beginning, a little bit confused and lost. You see, AI is a very general term and a multidisciplinary field. You can think of it as a tree with many branches, sub-branches. These branches, sub-branches of AI are overlapping in nature, and this makes it even more difficult for any company that is planning to adopt AI to come with a clear strategy and a solution. So each branch of AI has its own mathematical background, technologies, algorithms. So as we previously mentioned, these branches overlap, which make it even more difficult for any company to identify how to use AI to solve its real-world problems. So it was really difficult. It was the most difficult part. Although many marketers like to wax lyrical about AI, only few understand how to apply this kind of technology to actual business problems. All right, then. So let's see our approach at Warply. What was our solution? So our approach at Warply was first to break down AI into three smaller categories. I'd say three different types of technologies. First one comprises of our machine learning techniques. The second one are the applied propensity models. And the third one, and the last, is the general AI applications. The machine learning techniques involve smart and flexible algorithms which learn from historical data, and they are used to generate propensity models. The applied now propensity models, on the other hand, are used to predict specific events, such as scoring leads based on customer likelihood to convert. So it involves a lot of statistics. Finally, general AI application contain technologies usually associated with a human operator, such as chatbots, AI-generated content, and voice search algorithms. Taken all this together, all these technologies together, they comprise our data pre-processing pipeline. So what we did is that we find out how we could use each category across the customer journey. Each category has major implications for our customers and play different roles across the customer journey. Some are better, for example, for reaching new customers, while others are useful for converting and re-engaging past customers. Finally, we identified 14 types of AI technologies that can be used for our business across the customer lifecycle to take our customer down the marketing funnel. Okay. So just a moment, because I got a little bit confused here. I'm sorry. Okay, where we are here now. 5, 6, okay. Just a moment, I'm sorry, I've got lost a little bit. No, it's not this one. Okay, I'm sorry for this one. Okay, I'm really stressed, so apologize.
Can we get a round of applause?
So what we did is that we broken down AI into 3 different types of. Okay. Okay. So finally, we identified. So we're here. Finally, we identified 14 types of AI technologies that can be used for our business. Okay. So now we are going to mention a little bit, the customer journey and how we used all of these different types of AI technologies, and they blend very nicely here. So, the customer's life cycle contains 4 phases. The first one is the reach. The second one is the act, convert, and engage. So during the reach phase, what we did is that we attracted visitors to our website with a wide range of inbound techniques. At this stage, the customer journey, we use a combination of applied propensity models and general AI applications in order to reach new customers with more engaging experience. For the reach phase, as you can see from the diagram, we use smart content curation, AI-generated content, and voice search. For the act phase, we use machine learning and applied propensity models in order to draw visitors and make them aware of our products. So we use ad targeting, predictive analytics, lead scoring. So now during the convert phase, we try to nudge interested potential customers into becoming frequent customers. So what we do is that we use dynamic pricing, retargeting, web and app personalization, and chatbots. And finally, for the last and most important phase, which is the engage phase, we keep our customers happy and returning. So here we use market automation and one-to-one dynamic emails and predictive customer services. So this brings us to the next diagram. So once we came up with a solution how our company could use different types of AI technologies during customer lifecycle, we had to build our infrastructure in a way that could handle billions of events in real time. And this is, the core of the presentation. Okay, so our data pipeline consists of a hot and of a cold preprocessing parts. The cold part contains the machine learning and the deep learning models trained and tested, while the hot part makes real-time predictions, which are then delivered to a variety of applications, such as mobile apps, websites, e-commerce sites, and our workplace CRM. Let's now focus our attention on the cold preprocessing pipeline. Here's where our research and development data science team comes up into play. We collaborate with each other in order to build, train, and test our sophisticated prototypes. We follow the well-known agile methodology, which is very important. This part is very research-intensive, contains a lot of significant degree of uncertainty, and involves a lot of academic paper reading, new knowledge discovery, feature engineering, and iteration. And a lot of iteration. Those guys that are data scientists know how we are building these prototypes. So let's describe a little bit what's going on here. First, we get access to our Cassandra services, where we fetch raw historical data. Once the data is gathered, we clean it, we pre-process the data using Pythonic tools like Python and Dask. Usually this step is very heavy and time-consuming and involves a lot of iteration till we get our data ready for our machine learning, deep learning prototypes. These steps involve also a lot of data visualization and feature engineering. So our data sets contain many features if our data sets contain many features, we may use feature selection to eliminate those that are not important. I mean the features that are not improving the model accuracy. And this is done in order to reduce the model training time. Okay, so for the next part, now that we cleaned our data, we split the data into the training and test data sets. The next step involves, again, a lot of iteration. Still, we come up with a final, ready for production model. Usually, the most flexible, with the highest accuracy and the lowest loss score models are chosen for production. And, guys, we don't pay much attention at the model accuracy because, we want to build very flexible models, that then could be used by our data engineers and could be easily incorporated in our infrastructure. So I see that the time is off. However, we have another 10 minutes, right? Okay, great. Now, for the hot preprocessing pipeline, and it's a very high level description from a data scientist point of view. The pipeline of infrastructure streams billions of events from multiple sources to Kafka topics, which are then written to our Cassandra services. The deployed machine learning, deep learning models are used to make real-time predictions that are written back to our Cassandra database and finally served to the end user, which can be mobile app applications, our CRM, and variety of e-commerce sites. So some key points to take into consideration here. And these points are very important, comes from our experience, is not only we have the machine learning models, but we also have feature transformations. And the data transformation must be the same for the training data sets and for the test data sets. Furthermore, these transformations that we apply to the data are sometimes models by themselves. So, for example, take the principal component analysis or the TF-IDF that we apply when we are constructing a bug of words model. All these are models by themselves. So it's very important to transfer this transformation from the prototype to production. So until now, we talked on a very high level about our data infrastructure and how our company uses machine learning, deep learning to solve marketing, customer loyalty related business problems. However, we haven't answered yet the most important question, which is how we managed to adopt AI so successfully. So, from our experience, we believe that the recipe is to bring together the data scientists and the engineers to work together from the very beginning of our data or of machine learning and deep learning models. And to understand why this is important, we should first start to understand what data scientists and what engineers do, and how are different from each other, how they think, their duties, and how the tools that they use in their daily tasks different from each other. So on one hand, we have our data science team that are building, training and testing their prototypes, our prototypes, and deliver them these models to the engineers. Our job usually involves a lot of research, paper reading, statistics, and iteration. We use a lot of data preprocessing, like Pandas, Dask, tools for data visualization like Matplotlib and Dash, and tools to build our machine learning, deep learning prototypes like scikit-learn, Keras, and TensorFlow. On the other hand, we have the engineers that build fast and highly scalable infrastructure. And this brings us to the next slide. It's very interesting, I think, for you. And the most common scenario is where the data science team is separate from anybody else in the company. So consider the following scenario. Your data science team comes up with a model. They approach your engineers and ask them to deploy their prototype to production. So, exactly the words are, can we deploy this to production? Oh, we have this model. Okay, do it yourself. So the engineers have to read the, let's say, not so elegantly written by the data scientist code. They have to understand how the model works, how it can be added to the already existing infrastructure, if there is any, of course, infrastructure, and how to put all of these different pieces together and build the model from scratch. So literally they have to rewrite everything because it's impossible to be used as it is. So your engineers get down to work, and after 2 or 3 months of intensive work, they deliver a model to production. So everything works well. In the end, everybody in your company is happy, the management is happy, and both team rocks. But, and also there is a bit but, 1 month later, suppose you need to make a change. So the guys that are data science know about that. Perhaps your data science team came up with a new feature that improves model accuracy, let's say from 88% to 96%, which is wow. Or maybe you want to add some additional functionality. It can be anything. So guess what? The whole thing starts again. In the meantime, your data engineers work on some other, project, you don't know, and you can't change the code by yourself because either you don't know how to do it, or you are not able to touch it as the permissions go. So, or perhaps you lack the technical skills. For example, if the model has been rewritten in a different language. We, data science, build everything using Python. However, your data engineer team, for example, they can use, I don't know, Scala, or they can use Java because the code has to be very fast. So this approach, even if it's very common in any company today, is not very efficient. So the best, how did we do it? So the best scenario that works for us is where the engineers and data scientists work together from the very beginning of a project, from very early on. Even during research, our data engineers are involved. So what we achieved following this approach is that by the time the research is done, the prototype is almost ready, and by the time the prototype is done, it is essentially ready for production. Also, when data scientists create these platforms, they build tools and platforms for each other, so your data science team, for example, don't have to redo the same code over again. Okay, so this time, this brings us to the infrastructure where the data science team is usually separated from the engineers. So what I want to say here is that the best practice is to keep both teams together from the very beginning of a project. Because when you go to the production, you have to think of a lot of things such as model validation, deploying, error handling, versioning, logging. Also, we have security, all these different components that should be all connected together. So only when you bring your data science and your engineering teams together, you can deliver robust, highly scalable data products. So I see we have another 2 minutes. Okay, we're not. I think that. Okay, so now. In production, what we're doing is that we are always looking for fault-tolerated systems. You should always expect from this kind of machine learning, deep learning models, many problems, because there are so many parameters to take into consideration. So, for example, maybe your model doesn't converge, or the input data changes over time, and you should already always expect a lot of bugs and be prepared to solve them. So your models should always generate acceptable predictions and result, even when something goes wrong and fails. And yes, finally, your models should handle predictable error conditions automatically, and should be built in a way that allows your team to easily run diagnostics and recover in case of fatal errors. So I think that we don't have much time. I just wanted to say, about briefly mention, the libraries that you are using, both for production and for our prototype buildings. So we use Python mainly for engineering. We use also NumPy, SciPy, which we we are using in order to build our statistical models. For our machine learning, deep learning pipeline, we use scikit-learn. For deep learning, we use TensorFlow, which is very highly scalable and robust. It's a great, really great, guys, library. On top of that, we use Keras. And why we like Keras, and it's a very important point, and everybody should pay attention here, is that we can use Keras in order to push deep learning models onto mobile devices. So, it's very important. Just 1 minute, and I finish. It's very important because, you have your data science team, and you have your iOS development team. So, there are two teams from two different worlds. So, you can use Keras, build a model in Keras using Python, and only by calling a .convert method, you can deploy this model to the core ML libraries, which then can be used by your iOS development team in order to develop deep learning and machine learning prototypes and applications, mobile applications. So, okay. So, thank you all. I'm really sorry. I was a little bit stressed. I hope that you enjoyed a little bit of this talk.
So what I did is... I copy-pasted all of the questions because you have a lot of questions there, and you can take them all in the hallway or some other conference room after. Thank you very much. So all this you have in your Slack.
Okay.
Thank you very much.
Thank you.
Hello guys, I'm Vladimir.
And I'm Dimitris.
I am a data scientist at Berkeley. Dimitris is...
I'm a full-stack developer at Berkeley also.
So we just finished our presentation. I was, to be sincere, a little bit stressed. However, the audience is great. I think that went well. We really love the city. It's a great city, and we hope that we're going to enjoy time and to see some sights after this event. Thank you.